Okay, so for number 19 and 7.7, let's assume we have an angle theta that's between 0 and pi over 2, where the cosine of theta is 1/2. Right?
Get a triangle out?
Yeah, so we could get a triangle out. Which triangle do you want to get out, Zach?
30, 60, 90.
30, 60, 90?
Or 45,
Why?
45, 90.
Oh, one of the standard triangles?
Standard triangles.
I think 45, 45. I think the cosine of 45 degrees is. No, yeah.
Cosine
Yeah?
of
No?
something
Yeah?
is
No?
one.
Yeah? Oh shit. I don't
Because
remember.
45.
I'll get out both triangles, okay?
No,
It's the square root of 2.
Because
Here's the 45, 45, 90
And
triangle.
those sides are 1, 1, 2.
And those sides are 1, 1,
Square root of 2.
square root of 2.
Yes, that's gotta be.
And if you get up to 30, 60, 90 triangle, that one
Is 1, 2. But the tangent.
has 30, 60, 90. What are the sides?
1, 2,
Oh,
1,
1,
3.
Square.
Where?
So right there, that's square root of 3. That's 1.
That's
That's square. That's 1.
1.
1.
1. Square root of 3.
No.
2.
2.
Square root of 3.
Okay, so remember, right?
So cosine of 60.
You draw the 60, 60, 60 triangle, right? And then you cut it in half.
Yeah.
Label the sides too, and then cut it in
Don't cut
half,
it in half the silly way. Cut it in half the smart way.
right?
That's the silly way.
Okay, so which of these
60.
has a cosine of an angle is a half?
Pi over 60.
You're looking for cosine says you're looking for the adjacent over the hypotenuse, right?
60 degrees.
So you go over here to this one and you say, okay, no matter where I'm standing in here, the adjacent's 1 and the hypotenuse is square root of 2, right?
So you're screwed. You're left.
So that one's not doing this. Over here,
That's it. You point at it.
oh, okay, so I need 1 and the square root of 2.
Yeah.
So I think I'm looking at 60 degrees.
So
Pi over 3.
You guys see that?
5 over 3.
5 over 3?
5 of 3.
5 over 3.
Okay, so should be noted, this means that theta is pi over 3. Did I need all of that to figure out what the secant of theta is?
Not at all.
Well, you could just now reciprocate.
I didn't need any of that, right? Because the secant of theta is just 1 over the cosine. They told me the cosine was a half.
Yeah.
So this should be
2.
1 over a half, which is 2.
So true. And then tangent, well, you know your tangent.
Okay, so that one's easy. For tangent, you gotta work a little bit,
Just a
right?
little bit.
Tangent should be
Opposite of adjacent.
It's sine over cosine.
sine over cosine, which makes sense to look at because I know the cosine, right?
Yeah.
So it's something over a half.
Yeah.
So let's just find sine. On
Yeah,
the
so I need to
60
find
triangle.
sine, right? So one way I might find sine is I know what
The opposite.
the adjacent and the hypotenuse are,
Yeah.
So then an opposite.
so then I could figure out what the opposite is.
Yeah,
Square root
just
of
do
3 over
opposite
2.
adjacent.
So I do square root of 3 over 2
Divided by
over
1/2.
1 over 2,
And then
which is square root of 3 over 1.
square root of 3. That's what I was trying to say. I was like, and.
Is with me?
Yes.
Okay, did I need to know that the angle was pi over 3 for that?
You could have used that, but you did not need to know.
Yeah, I didn't actually
Did you?
need
Really?
to
But I
know
would
that.
have used it. I would have used it to do opposite over adjacent.
Well, you probably just, you could have just used cosine.
Yeah,
You just
so
had to found sine.
I
You
think
just
what I
had to
could
found
do is do this, right? I have a triangle, I don't know what triangle, but in that triangle, there's a theta, and the adjacent side is 1, and the hypotenuse is 2,
sine. Yeah.
right?
Piece it together.
And then I need the opposite side. So I could be like, okay, so over here, right, this is 2 squared minus 1 squared, and then square root the whole thing,
Yeah.
4 minus 1.
right, by the
which is
Pythagorean
square
theorem.
Mhm.
And then you do the opposite over the adjacent, you get the same thing.
Yes.
root. Yeah, so you could
You
have just
follow
pieced
that?
it together.
Yes.
But that would help me if I didn't actually, like if this wasn't a standard angle.
Right.
If this was 1 over 3 instead of 1 over 2,
Mm-hmm.
I could still solve this problem.
Yes.
You guys cool with
So cool.
So if it's not, then just plug it into a triangle.
that? Yeah,
That would apply to the.
if it's not one of the standard angles and you need to calculate some other trig functions from a known one, just assume something, like just draw a triangle to represent what's going on, and just start labeling the sides and use the Pythagorean theorem to figure out the other ones.
Sick.
That's a trick you'll use in trig class, or not in trig class, in
Yeah.
Calc 2. You'll end up with this thing where you're looking at,
Is it the same as Calc B, or is it Calc A and B?
it's Calc B.
Calc B. Do you have
So you'll end up with this problem where you know that the cosine of theta is 1 over x, and you'll want the tangent of theta,
Yeah, that makes sense.
right? And Merrill calls this triangle time. So you draw a triangle, right?
Square root 2.
Like,
x
okay,
squared
so
minus-
here's a triangle, and this is the world's shittiest triangle. You'll label your theta. You'll say, okay, what do I know about this? Well, I know the adjacent side is
1.
1, and the hypotenuse is x.
So it's going to be x squared minus 1.
And then I figure out what this is.
Yeah. Fair enough.
Right, so this would be the square root of x squared minus 1. And so the tangent then would be square root of x squared minus 1.
Yeah, that makes sense.
Cool with that trick?
Yeah.
C.
Because that, yeah.
So that trick is super, super useful.
Yeah.
If you do not know that trick, you will hemorrhage points on one of the Calc 2
If
tests.
you do not know that trick,